These are solutions for Melham's Math 251 at CSM, the Chapter 2 exam. In number 1, find the slope of the secant line joining 1 f of 1 and 1.01 f of 1.01. The function is x squared, so you plug in 1.01 squared minus 1 squared divided by 1.01 minus 1 comes out to be 2.01. Number 2, limit as x approaches 0 from the left is 1. Limit as x approaches 0 from the right is negative 1. But f of 1 is right at 2. Number 3, limit h approaches 0 of radical 9 plus h minus 3 over h. Multiplied by the conjugate of the numerator, radical 9 plus h plus 3 over radical 9 plus h plus 3. So it's going to be a squared minus b squared. If I square this, I just get 9 plus h. Minus the square of 3 is 9. Over h times radical 9 plus h plus 3. Cancel out the 9s. You're left with an h, but you can cancel that h, so I'm left with a 1 on top. So limit h approaches 0 of 1 over radical 9 plus h plus 3. Now I plug in 0 for h, 1 over radical 9 plus 3, 1 over 3 plus 3, 1, 6. Number 4, plug in x equals 2 for both the top and the bottom of the two expressions. So you plug in 2 to the top, you get 4c. Plug in 2 to the bottom for x, you get 2c minus 3. Subtract 2c and divide by 2. c is equal to negative 3/2. Number 5, key is to notice that when you have radical x to the 4th minus 2, the square root, if you ignore this part, it's essentially x squared. So it's behaving like a second-degree polynomial. So divide top and bottom by x squared. I've divided by x squared. This is dividing by x squared because it's x to the 4th underneath the radical, which is the same as x squared outside the radical. Okay, x squared over x squared is 1. X to the 4th over x to the 4th is 1. 1 minus 2 over x to the 4th. Now when x gets real big, this expression becomes 0. 1 over radical 1 minus 0. 1 over square root of 1 or 1. Number 6. First, I notice that it's an even function. If you replace x by negative x in both of these, you get the same thing. So I'll have symmetry with respect to the y-axis. So I can just worry about the right side and do a mirror image on this side. This factors into x squared times x squared minus 9, or x squared times x plus 3, x minus 3. My zeros are 0 and plus or minus 3. Okay, so maybe I'll just forget about this part. Just look over here. But we had the zeros, negative 3, 0, and 3. If I plug in a number like 4, these are all positive, so it shoots out toward infinity. Pick a number between 0 and 3, like 1. That's always positive. 1 plus 3 is positive. 1 minus 3 is negative, so it'll go down and then back up. And then because of y-axis symmetry, I just trace the same thing over here. So that's my graph. All right, so what I have here, f of plus or minus 1 is less than 0. If I put either a 1 or negative 1, I end up with a number less than 0. And when x approaches either positive or negative infinity, then y approaches infinity. Okay, and you can tell here, if I plug in a super big number, it's big positive, big positive. And if I plug in a big negative number, same thing, big positive times a big positive. 7, the equation of the tangent line. So that means derivative. So you want the derivative of square root of x. So y prime is limit h approaches 0, radical x plus h minus radical x all over h. Again, multiplied by the conjugate, recurring theme. Radical x plus h plus radical x over radical x plus h plus radical x. So this is a squared minus b squared. If I square this, I just have x minus x plus h. If I square this, I have minus x. Leave the bottom alone. X minus x is canceled out. I have an h, which cancels that h. 1 on top. Limit h approaches 0. 1 over radical x plus h plus radical x. Now I plug in 0 right there. That gives me radical x plus radical x, or 1 over 2 radical x in the denominator. Okay. They give me the point as 4, 2. I plug in x is 4. You don't have to do anything with the y equals 2 because the expression doesn't involve y. So I want y prime of 4. So it's 1 over 2 radical 4. That's 1 over 2 times 2, which is 1/4. And throw it into the point slope form. The point was 4 comma 2, and the slope is 1/4. So y minus y1 equals m times x minus x1. Y minus 2 equals 1/4 times x minus 4. 8, we're trying to estimate the slope of the tangent line near the origin of the sine function by picking a nearby point, 0.01, f of 0.01. So f of 0.01 is sine of 0.01 minus the sine of 0, 0, divided by 0.01 minus 0. It comes out to be 0.9999, which is approximately 1. So we're going to use m equals 1 as our slope. So y minus y1, y minus 0, equals m1 times x minus 0, or simply y equals x. So the tangent line to the sine function at the origin is y equals x. Finally, find a derivative of x cubed using the definition of the derivative. Okay. So limit as h approaches 0, x plus h cubed minus x cubed all over h. Okay. You know how to multiply that out. You can use Pascal's triangle. I showed you that. Or if worst comes to worst, literally take x plus h squared and take that answer and multiply it by x plus h. Comes out to be x cubed plus 3x squared h plus 3x h squared plus h cubed minus the original x cubed by h. X cubed cancels with x cubed. I have that one, and that one. They all have a common factor of h. So factor out the h. Limit h approaches 0. H parentheses 3x squared plus 3xh plus h squared all over h. H's cancel out. Limit h approaches 0. 3x squared plus 3xh plus h squared. Now I plug in 0 for h. That's gone. That's gone. So I'm left with just h squared. Right, so these are solutions for Melham's Math 251 at CSM Calculus 1, the Chapter 2 exam.